Hi, everybody. This is Professor Dan G at the University of Colorado Boulder. And now we're working on our third homework. And we call it homework 2 because we're zero indexed, because we're starting to think somewhat like computer engineers. And by now, your R and K homework, you should get the feeling that, yeah, the hardest part is actually getting the problem set up. So we're going to spend a little more time on our MATLAB today just to make sure we're feeling good about MATLAB. That's our GLOT. So yeah, let's go through this, see what we got. All right, so we fire up our MATLAB and all these exercises I've been using the MATLAB online. Um, like we said in an earlier video, you can download it if you want, but MATLAB Online for our course is all you really need. And what we're going to start to do is really use this script window. So first thing I do is I call it something. So I save it as File, save as, and I called it homework 1 walkthrough. So that's what we'll call this. And remember from last time, there's 3 commands. There's actually 4 commands that we like to have at the start of every script. And that's first we CLC, which clears our command window. Then we say clear all, and that clears our workspace. And then we say close all. And that's if we have a figure, it'll close that. The other thing we know is that MATLAB has weird formatting for its numbers. I don't really know why they do that. They probably have a great reason, but for me as a human, I always like to say format short or long G. So we say format short G, you can say format long G if you want to see more decimal places, but that makes it so when we're using arrays, we see the numbers that we expect to see. All right, so now what's our homework look like? So let's go, let's see what we got. So homework 2. So we start with GLOT chapter 1, number 6. And so, it's a similar program. It says, define the variable z as z equals 4.5, then evaluate, just some expressions. So if I go into it, I just have to, in my script editor, I can just say z equals 4.5. And then it says evaluate, so I'm going to say, oops, before I do anything, remember, it's always good to leave a comment about what you're doing. So this is chapter 1, 6. And this is A. So if I say z equals 4.5, I'm not going to do the whole problem. But remember, if I just say, so part A equals 0.4 z to the 4th. Let me just try to run that. It's going to give me an error. And it's because we always have to tell MATLAB to multiply things. We can't, when we look at math, it just says if a number is next to it, we can multiply it. But now I'm just going to say multiply. And yeah, so we can say, just use MATLAB like a calculator. We call z as 4.5 as a variable, and then we go through that. So that's just a little review. Hopefully that's not too bad. I'm going to leave the rest for you to kind of work out. All right, so now chapter 2, number 13, and it says read chapter 2, 35 through 44. Do that. Definitely read chapter 2, pages 35 through 44, because this is kind of tricky. Yeah, so chapter 2, our first problem is 13. It says use the colon symbol, create a variable named 7s that is a row vector of 7 elements that are all number 7. So if I read 35 through 44, I see that these colons have like a very special way to think about when we use MATLAB. And so if I say chapter 2, 13. All right, so let's try something. So one way that we tried last time is, so if we call it 7s equals, and then we can say 1 through 7 by 1. So when we have these colons, we can say 1 is what we start, 7's where we end, and in the middle is what we're going to count up as. So if I hit run there, they're not all 7's. If I do 1 by 7, Ah, just give me 1. Hmm. So if I put it on the left side, it's a little hard. I could just do this, 7, 7, but that's not what it wants us to do. It says using a colon. So one way to use a colon is, like I said, 1 through 7 in brackets. Let's see what that does. Is that even going to do anything? Yeah, just imagines the step is 1. Another way to think about our colon is on the left side here. So I can say I have this array called sevens, and if I say 1 through 7, or I'll say, let's call this threes. And if I say 1 through 3 is equal to 3, that says for this array that I'm calling threes, in position 1, 2, and 3, I want to put a 3. See how that works. Oh, look at that. And the reason why this is powerful is, again, I can just type in threes is equal to 3, 3, 3, 3, and get the equivalent result. But what if I want hundreds? Ew, I don't want to do that. I don't want to type in 100 numbers. If I type in hundreds, 1 through 100 is equal to 100. Check that out. Now I got all hundreds. So with that information, you should be able to get far on this program. The other way to do it is, what if I do fours? And it says in our help, it says you can also use the ones command. So if I do fours and I call that array and I just say ones, that is 4 long. Let me try that. Oh, it gives me 4. So, oh, look at that. You have to, so read pages 35 through 44, see that 4, I can give myself a ones. That's 1 row by 4 columns. And so you see that gives me a bunch of ones, but I can multiply that times 4 and give myself a bunch of 4s. So with that, I think you have enough hints to get started with that sevens command. All right, let's see our next. Oh, we got to do 19. All right, so 19 is another one of these vectors. All right, so chapter 2, 19. So it says create a row vector A. A is 4 by 3 up to 13. And a column vector B is equal to 14 by -2 to 6. We run that and we see we actually have 2 row vectors. Remember, we have to have our little apostrophe, so it turns a row vector into a column vector. There we go. And then it says, then using only the names of vectors A and B, create the following: a row vector C that is made from the elements of B followed by the elements of A. Huh. Well, that's interesting. So one of the things that's fascinating is that we can so I don't want to do this problem totally for you, but think about it. If we have the elements of B followed by the elements of A, we can just type in C is equal to the elements of B followed by the elements of A. Seems to make sense. Uh-oh, but we can't, because this A is a row vector and B is a column vector. So how do we make B a row vector? And I'll give you a hint. It's all in that apostrophe. So that's a pretty big hint. And yeah, I want you to play around with those apostrophes. Where you put them is potentially right after B or right after A, depending if you want to end up with a row or a column vector. All right. So let's see our next problem. All right, chapter 5. All right, so chapter 5, number 2, is a plot. And so it says, make sure to read, or make sure to label your axis, but it says read chapter 5, 133 to 148. 133 to 148. And this is all about plotting. And plotting, we have X and Y, so I really want you to read chapter 133 to 148. But let's say it says do chapter 2, so I'll get you started with, or do problem 2, so I'll say do problem 1. So it says use the plot command. So chapter 5, I'll do 1. So it says use the plot command. And it says the function, and we can also say function y is equal to x squared plus or minus 10 times the square root of x, or we can say x to the 0.5 plus 2. Then it says x from 0 to 5. Let me say plot x comma y, and then there's a filling in things pretty annoyingly, but that's okay. All right. This isn't going to work. And so one of the things that's important is to make sure we're reading, and then we make sure we see these hints. So 139, 139, it says, see example on page 139 for creating an x vector. So if we look at this, it says plot the function y equals 3.5 to the minus 0.5x cosine of 6x for x minus 2 less than or equal to x less than or equal to 4. And we see we use our colons to create a vector of our x variables. So we need to give MATLAB some x values. How do we do that? Well, the number one thing is if we have y that is using x, we want to make sure we have x beforehand. And we say if x was from 0 to 5, that would work, but it would only have 5 points. So we're seeing on page 139, give yourself enough points. And so this one says, by 0.01. So let's do that. X goes from 0 to 5. And let's say we go from 0 to 5 by 0.01. Then we have y equals x squared minus 10x to the 0.05 plus 2. When we run that, and it's going to give us an error. And it's because this is a matrix, and there's some very distinct rules of matrix operation, which we actually don't even know yet. So how do we do it? Well, one of the things it says to operate on each element of the matrix individually, use the little dot power. So when it's x squared, that's x times x, but we want just the first term multiplied by the first term, the first element multiplied by the first element. So we use this dot. And then we have 10, and we're raising x to the 0.5. So we use another dot, and we see that solves our issue. So that element by element really helps us. So that says plot. So yeah, x squared minus 10, x to the 0.5 plus 2. All right, and it says label. So we'll say x label. We'll call it X. We'll say Y label. We'll say Y, and we'll hit go. See if that works. Ah, messed everything up. So when we tried to label, we messed things up, and it's because we need to tell MATLAB that these are characters. So we put them in apostrophes. We do that. Boom. good to go. All right. So yeah, just try that for problem 2. It's pretty similar. All right, so the last thing we need to do is our check. So solve R&K Chapter 3, Problem 37A using MATLAB. All right, so we look at 37A. Oh, it's this motion capture study. I'll give you a hint. Check 1. By now, you should know that the angles you see aren't our theta 1 and theta 2. Remember, theta 1 and theta 2 for our robot problems are very specific. So theta 1 is actually 180 minus 30 by our definition. And our theta 2 is 180 minus 60. Is it? All right, you tell me. And then we just type in our our equations from class. So the key to this problem is making sure you have the correct theta 1 and theta 2. So make sure you're doing that right. Hey, make sure I'm doing it right. And yeah, that will definitely help. So with that, I'm going to sign off. And if you have other questions and you're in class, come on, bring them by. Hopefully that helped you get started with these, and we'll see you in the next video.